Let us start. This is the fourth video on vectors and scalars. In the last, before getting into the concepts, see the subtitles are available. I have edited the subtitles. You can use subtitles while you are watching the video. That is one point, and one more point I want to discuss is what is the resultant. See, when you add two vectors, the sum of the vectors, we call it as resultant vector. Resultant. In the last class, I forgot to mention this. The sum of two vectors, we call it as resultant. Understood. Next thing, for addition of vectors, there are two laws. One is the triangular law. So we are discussing on vector addition. So in the last video, we were discussing on addition. So the triangular law we discussed in the last video. So there are two laws for vector addition. One is triangular law. Second one is the parallelogram law. So in the last video also we discussed when we will go for triangular law and when we will go for parallelogram law. The triangular law we use is when the vectors are in order. If the vectors are not in order, we will use parallelogram law. What is in order and not in order? See, if two vectors, both of them are in clockwise direction, they are in order. If both of them are in anti-clockwise direction, they are in order. If one is clockwise and another one is anti-clockwise, this is not in order. So this is in order because both of them are in clockwise direction. This is in order, both of them are in anti-clockwise direction. These two vectors, one is in the clockwise direction and another one is in the anti-clockwise direction, so they are not in order. So if the vectors are in order, we use triangular law. If the vectors are not in order, we use parallelogram law. What do you mean by the vectors are in order? If both the vectors are in clockwise or both the vectors are in anti-clockwise, they are in order. If one vector is in clockwise direction and the other vector is in anti-clockwise direction, they are not in order. You understood? In the last video, we discussed this. Clear? Now, we will come to the parallelogram law. The triangular law we already discussed in the last video. You can watch the previous 3 videos, then you will get a clarity on vectors. So this is the 4th video. Let us continue with parallelogram law. So parallelogram law uses when the vectors are not in order. For example, this is one vector and these two vectors. This is another vector. This is vector A and this is vector B. So these two vectors are not in order because vector B is in the clockwise direction, vector A is in the anti-clockwise direction. So these two vectors are not in order, so we will use parallelogram law. So what is parallelogram law means? See, triangular law, if the vectors are in order, we use triangular law. What is triangular law? If two vectors are in order, see like this, we have taken the example of displacement, we start from here and end here, then we will complete the triangle and the resultant, this is the resultant. This is resultant means sum. This is vector A and this is vector B. So this is starting from P and going to Q and then reaching R is equal to traveling directly PR. That's why vector A, this vector R means vector A plus vector B. To get this, we completed the triangle. That's triangular law of vector addition. What is triangular law? If two vectors are represented, this law you need to write it like this. Even in the last video I told you. If two vectors are represented in magnitude and direction by the adjacent sides of a triangle taken in order, then the sum is represented in magnitude and direction by the third side of the triangle taken in the reverse order. That is triangular law. Let's come to the parallelogram law. See, to get the triangular law of addition, you completed the triangle. To get the parallelogram law of addition, you need to complete the parallelogram. So here we will construct a parallelogram with these two sides. Then after constructing the parallelogram, we will draw the diagonal through these two vectors. At the intersection, you will draw the diagonal. This diagonal will give you the resultant vector. This is vector A plus vector B. Let this angle is theta and this angle is alpha. Understood? So vector R, vector A, vector B. So what is parallelogram law? If the vectors are not in order, if the vectors are not in order, we will use parallelogram law. What we will do? In triangular law, we completed the triangle. In parallelogram law, we complete the parallelogram, then the diagonal passing through the intersection will give the sum. This is vector R resultant sum, vector A plus vector B. This you need to understand, this angle between the vectors is theta, and this angle, the resultant and vector A is alpha. So the statement, the law, like this you need to tell, if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram taken in reverse order, not in order. They are in reverse order, taken in reverse order, in order and reverse order. In order means both of them should be in clockwise. Reverse order means one is clockwise, another one is anti-clockwise. In order means both of them will be clockwise or both of them will be anti-clockwise as well. Reverse order means one is clockwise, another one is anti-clockwise. Got it? So if they are in reverse order or not in order, we will go for parallelogram law. If both the vectors are in order, we will use triangular law. So what is parallelogram law? Parallelogram law of addition of vectors means if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram taken in reverse order, then the sum is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point, drawn from the intersection of these two vectors, drawn from the same point. Once more, you can write this definition if you need. If two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram taken in reverse order, then the sum is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. You understood? Now, so these two vectors are not in order. This is case 1. Now, if it is case 2, I am taking like this. This is case 2. They are not in order means one vector is like this and another vector is like this. So this is clockwise, they are not in order, they are in reverse order. Then how do you complete the parallelogram? There, see, like this, you need to extend this vector. You can move the vectors parallel. That is the equality of vectors. If two vectors are equal in magnitude and direction, those two vectors are equal. All parallel vectors are equal. Parallel vectors in the sense with same magnitude. See, this is vector A, same magnitude, same direction, vector B parallel. So it must be equal, but both of them have the same magnitude and same direction. Direction also same. They are parallel vectors. You are able to see this? See here, like this. This is vector A. The same magnitude and same direction. If I am taking vector B, then vector A is equal to vector B. That's what I am telling. See, in the same way, this is vector A and this is vector B. I moved vector A like this. Then I can move this vector B like this. Then you can construct the parallelogram. Here you cannot construct the parallelogram. It's not possible. Not possible to construct the parallelogram here. Now you will have the resultant R, and this is vector A plus vector B. So if the vectors are like this, here they are not in order, then you need to extend this, or you are moving the vectors parallelly. You are or extending the vectors, and you will construct the parallelogram. This is case 2. You understood? It's simple. See, equality of vectors tells that if two vectors are equal, they must be having the same magnitude and same direction. See, here same magnitude, same direction, same direction. So this is vector B means this is also vector B. Same magnitude, same direction, then same direction. Then this is vector A means this is also vector A. Understood? Then after that you will construct the parallelogram. Here the problem is, here you cannot construct the parallelogram. In this way you cannot, but here it's easy. That's why you are moving the vectors like this. Here you cannot, not possible to construct the parallelogram. Here you can construct, and this is the diagonal. So these two cases you understood. Now, so what is the value of this resultant? The formula, this formula is the most important formula we are going to discuss in physics, in math, everywhere, in engineering, wherever you go, this formula is very important. So what is the resultant? The formula is vector R is equal to the modulus of vector R, magnitude. Modulus is magnitude. Resultant vector sum is equal to root of A square plus A is the magnitude of this vector A square. Modulus of this vector A plus B square, modulus of this vector B plus A square plus B square plus 2AB cos theta. 2AB cos theta. What is theta? Theta is the angle between the vectors. Very important. Theta is angle between vectors. Theta is angle between vectors, vector A and vector B. R is equal to root of A square plus B square plus 2AB cos theta. Clear? You understood this formula? What is R here? Resultant. Resultant means sum. The sum of the vectors is denoted by the term resultant. What is A? This A means magnitude of vector A. For example, this is 5 Newton means here you will put 5. What is B? Magnitude of vector B. What is 2AB? Understood. Cos theta. What is theta? Angle between the vectors. Clear? Now one more formula. What is this alpha? Alpha gives the direction of the resultant. Direction of resultant vector. See, this resultant vector makes an angle alpha with vector A. Then what this is very important formula? Tan alpha is equal to, this is the formula, B sin theta divided by A plus B cos theta. B sin theta divided by A plus B cos theta. Clear? Tan alpha is equal to B sin theta divided by A plus B cos theta. What is B? Magnitude of vector B. What is A? Magnitude of vector A. What is theta? Angle between the vectors. So what is the significance of tan alpha? Tan alpha gives the direction of the resultant with respect to A. Tan alpha gives how much the resultant is inclined to vector A. Tan alpha signifies the direction of resultant. Direction of resultant vector. Understood? Tan alpha. So tan alpha is equal to B sin theta divided by A plus B cos theta. So that's parallelogram law. Now, see, let us find out this parallelogram law is, see, one important thing in the case of parallelogram law is, see, one vector is in this direction acting on me, this direction, okay? Or you can think like this as well. One vector is acting like this, that means in this direction, and another vector is in opposite direction. That means